Now let's try to find out Kp and Kc of a general reaction which is A is at equilibrium with B and C. Now let us suppose the initial moles of A, let it be N, or I can say let it be C. At initial time there will be no products, so this will be equal to 0, this will be equal to 0. Now after some time t, what will be the moles at equilibrium? So we will write moles at equilibrium. Now there will be some moles that will be dissociated from the reactant and products will be formed. So if I say that X number of moles are dissociating, then X will be formed for B and X will be formed for C. Now, or we can also write it as C minus C alpha or C alpha or C alpha. Now this is the number of the moles. Now to calculate Kc for any reaction we need concentration. So our next step will be, what will be the concentration at equilibrium? We very well know that concentration is equal to number of moles divided by volume. So if we are considering these moles, so let's volume is equal to V, so concentration of reactant will be equal to N minus X by V, and for product it will be equal to X by V or X by V for C. Now if I am considering in the terms of C minus C alpha, so I can write that concentration will be equal to C minus C alpha upon V or C alpha upon V or C alpha upon V. So this is our concentration at equilibrium. Now we know that value of Kc is written as the product of concentration of product, in this case it is B, and C divided by the concentration of reactant. As there are 1 mole of A producing 1 mole of B and 1 mole of C, so the powers are 1, 1 and 1. Here also if it is 1 mole of A, we are considering its dissociation as X, so 1 mole of B generated will be equal to X and X for C also. Now if we write the value of concentration of B from here, that is N minus X by V, or I can write it as C minus C alpha upon V. So we can write Kc is equal to, what is the concentration of B? Concentration in the case of B is basically equal to X by V. So this is our X by V multiplied by concentration of C. So concentration of C is equal to again X by V, that is X by V divided by concentration of A. So concentration of A is N minus X by V. So that is n minus x by v. So our final result will be Kc is equal to x square by n minus x into v. Or if we write it in terms of considering these concentrations, then value of Kc will be equal to C alpha square upon 1 minus alpha into V. So this is our expression for Kc for this generalized reaction of A giving you B plus C as product, 1 mole of B and 1 mole of C as product. So what is important to note here is we can clearly see that the value of Kc is basically dependent upon volume. This is the general mistake committed by students. They don't consider volume in the question. So this is important, and this is only for the case if the general expression is A giving you B plus C. Now, how to calculate Kp for this particular reaction? For calculation of Kp, now Kp can be written in the terms of pressure, that is pressure of B, partial pressure of B into partial pressure of C by partial pressure of A. Now we know that partial pressure of any compound is given as its mole fraction multiplied by total pressure, that is, let us say it is equal to Pt. Now how to calculate mole fraction of A? This would be equal to number of moles of A divided by number of moles of A plus number of moles of B if there are two components. If there are three components, then it will be Na plus Nb plus Nc and so on. Now, what is the number of moles of A for our particular case? This was A, this was B concentration, and this was C concentration, and moles were, these were the moles for A, these were the moles for B, and these were the moles for C. So in the place of number of moles of Na, I can write, considering these moles at equilibrium, that is C minus C alpha. So I can write the value of Na as C minus C alpha divided by, now here it's not about Na or Nb, it's about basically the total moles. We define mole fraction as the ratio of moles of a component divided by the total moles of all the components, or the total moles of the reaction. Now for this particular reaction, what will be the total number of moles? Total moles. Now total moles at equilibrium will be basically equal to C minus C alpha plus C alpha plus C alpha. So I can write that total moles will be equal to C minus C alpha plus C alpha plus C alpha. This will cancel out. So we will see that total number of moles can be written as C plus C alpha. So here the value of total moles comes out to be C plus C alpha, that is C plus C alpha. So taking C as common, we can write that XA comes out to be equal to C is common divided by C 1 plus alpha. So XA basically equals to 1 minus alpha divided by 1 plus alpha. So now it is easy for us to calculate the value of PA. So we can write that PA is equal to, what is the value of XA? XA was equal to 1 minus alpha plus 1 minus alpha divided by 1 plus alpha. So PA is equal to 1 minus alpha divided by 1 plus alpha multiplied by P total. Similarly, we can also calculate PB, that will be equal to XB into P total. Now, how to calculate XB? That will be basically equals to number of moles of B by total moles. Now, what were the number of moles for B? Moles for B were equal to C alpha. So I can write it as C alpha divided by, what were the total number of moles? Total number of moles were equal to C plus C alpha, that is C plus C alpha. So C will be common, 1 plus alpha, C cancels out. So what is the value of mole fraction for B? XB comes out to be equal to alpha by 1 plus alpha. Hence, we can write the value of PB as putting the value of XB, that will be alpha divided by 1 plus alpha multiplied by P total. So here we have two terms, that is PA is equal to 1 minus alpha 1 plus alpha into P total, PB is equal to alpha by 1 plus alpha into P total. Now we are left with PC, how to calculate the value of PC. Now for PC, partial pressure of PC will be equal to mole fraction of C multiplied by P total. Now how to calculate the mole fraction of C? That will be equal to number of moles of C divided by total moles in this case. So what was the value of number of moles of C? So moles at equilibrium for C, that was equal to C alpha. Hence, we can write that NC is equal to C alpha divided by what was the value of total number of moles? We had calculated that total number of moles were equal to C plus C alpha. Hence, it will be equal to C plus C alpha, which can be written as C alpha by taking C common. So this will be equal to alpha by 1 plus alpha. Now, putting the value of Xc here, we will get alpha by 1 plus alpha into P total. Now, we were interested in calculating Kp. We were interested to calculate Kp. Kp was equal to Pb into Pc by Pa. So, we have come upon with the value of Pa as well as the value of Pb as well as the value of Pc. So, putting the values of Pa, Pb and Pc in this equation, our Pb was equal to alpha divided by 1 plus alpha into P total, multiplied by Pc. Pc is equal to alpha divided by 1 plus alpha into P total, divided by Pa. The value of Pa was equal to 1 minus alpha divided by 1 plus alpha into P total. So, that is equal to 1 minus alpha divided by 1 plus alpha into P total. Now, proceeding further, we can write Kc is equal to alpha square into P total square divided by 1 plus alpha square divided by 1 minus alpha divided by 1 plus alpha into P total. Hence, this can be written as P total will cancel with 1 P total. So, this can be written as alpha square into P total divided by 1 plus alpha square multiplied by 1 plus alpha divided by 1 minus alpha. Hence, cancelling 1 plus alpha with this, one value of 1 plus alpha will cancel out. So, we are left with alpha square into P total divided by 1 plus alpha, that is left from here because there was square, multiplied by 1 minus alpha. Sorry, I have written Kc here, it is not Kc, it is Kp. Sorry for that. We are calculating Kp, not Kc. Kp is equal to Pb into Pc by Pa. So this is the value for Kp. So Kp will be equal to alpha square into P total by 1 plus alpha into 1 minus alpha. So we can see that Kc is equal to, Kc was equal to C alpha square divided by 1 minus alpha into V, and Kp was equal to alpha square into P total divided by 1 plus alpha into 1 minus alpha. So this is how you calculate Kp and Kc for a generalized reaction of A giving you B plus C. This is the value of Kc, this is the value of Kp.